We're all living through this insane AI gold rush, right? I mean, every single week there's a new breakthrough, a model that's more powerful than the last, and this just unbelievable demand for the chips that make it all happen. But what if this entire boom is about to slam into a massive, hidden wall? A bottleneck that isn't where most of us think it is.
You hear about chip shortages all the time in the news, but the real story is so much more complicated than just, make more chips. It's more like a giant puzzle with all these interlocking pieces, and some of those pieces are getting really, really hard to find. So what's the actual roadblock standing between us and this AI future everyone's talking about?
So, where's the real problem? Well, it's probably not where you're thinking. The issue isn't really in creating the raw silicon anymore. The real traffic jam, the critical choke point, is happening at the very end of the line, that final, super delicate stage of putting all the pieces together. So let's get right into it and start at the heart of the problem. We're going to piece together what I like to call the final assembly puzzle. Okay, so you need to think of a modern AI processor less as one single thing and more like a super high-performance kit that has to be assembled. First, you've got the brain. That's the advanced logic chip that does all the heavy thinking. Then you need the memory, and we're talking about a special, crazy fast kind called high bandwidth memory, or HBM, that just fire hoses data to the brain. And finally, and this is the really critical part, you need the connection, a process called advanced packaging, that fuses these two things together with mind-blowing precision. And that right there, that is the immediate problem. You could have mountains of the world's most powerful brains and piles of the fastest memory, but if you don't have the ability to perfectly connect them together at scale, you've basically got nothing to sell. That final packaging step is the traffic jam that's slowing the whole parade down. Okay, so if packaging is the problem, what's causing it? To really get that, we need to zoom in a bit and look at the three key technologies that are creating these hurdles. So it all starts with this wild technology called EUV. This is basically the one and only hyper-advanced factory floor where the AI engines, those logic chips, can be built. A single company, ASML, has a total monopoly on this tech, which makes them the absolute foundation for all next-gen AI. The number of these machines they can build literally sets the long-term speed limit for the entire industry.
But an engine is pretty useless without fuel, right? That's HBM. Now, this is not your standard computer memory. Think of it like pure, high-octane rocket fuel. It lets the AI engine gulp down enormous amounts of data at incredible speeds. If you run out of HBM, even the world's most powerful AI chip just sputters out and stalls.
And finally, you have to put the engine and the fuel together. That's CoWoS. This is the master assembly line, pioneered by TSMC, that takes those two parts and masterfully integrates them into a single, powerful unit that's ready to go into a server. This is that final finish bottleneck we were just talking about.
Now, this is where the story takes a really interesting turn. See, for the longest time, the world of advanced packaging pretty much revolved around one company, TSMC and their CoWoS technology. But that's starting to change.
While TSMC is definitely still the king of the hill, Intel has now jumped into the ring as a serious contender with its own packaging tech called EMIB. Don't think of it as a direct replacement, but more like another path to get to the same mountaintop. And why does this matter so much? Because it means advanced packaging isn't a monopoly anymore, and that competition could be a huge step toward easing this whole bottleneck.
So we've covered the tech, but the constraints, believe it or not, don't stop there. In fact, some of the biggest roadblocks have absolutely nothing to do with technology. We have to zoom out even further to see the landscape of people, power, and politics.
Take a look at this number, 1 million. According to a Deloitte analysis, that's the estimated number of additional skilled workers the global semiconductor industry is going to need by the year 2030.
And that number is so critical because it points to a huge mismatch. This is not just a simple hiring problem that you can solve with a few job fairs. The AI hardware industry is expanding so fast that our education systems and training pipelines just can't keep up. We physically can't produce the specialized talent fast enough.
And this human bottleneck has very real consequences. It means new factories get delayed. It means it takes way longer to get new production lines running at full speed. It gets a lot harder to maintain quality control. And ultimately, the pace of innovation itself can slow down. All because the people you need to push things forward are stretched way too thin.
And as if a massive talent shortage wasn't enough to deal with, there's another layer on top of all this that can just override everything else: geopolitics. And this isn't just some background noise, it's now become a primary control switch for the entire AI hardware supply chain.
Two big issues really stand out. First, you've got export controls. US-led regulations now pretty much dictate who can and cannot buy the most advanced chips in HBM, and that's fundamentally reshaping huge markets like China. Second is geographic concentration. An overwhelming majority of the world's most advanced chipmaking still happens in Taiwan, and that concentration creates a potential single point of failure that is, frankly, a major concern for global stability.
Okay, so we've laid out all the pieces. The tech hurdles, the people shortage, the political risks. Let's try to assemble them into a kind of roadmap to see how this incredibly complex bottleneck is probably going to evolve over time.
Here's how to think about it. In the short term, like right now, the most intense pain is coming from advanced packaging. As we look ahead to the midterm, the focus is going to shift to a 1-2 punch of both HBM and packaging capacity being in short supply. And then in the long term, the ultimate ceiling, the final boss, if you will, is going to be the very foundation of the industry, just raw manufacturing capacity, which is governed by those incredibly complex EUV machines.
And this table really lays it all out. The AI bottleneck isn't just one thing. It's a whole interlocking system of constraints. You've got the technology hurdles we discussed, the huge people problem, the geopolitical wildcards, and you can't even forget basic infrastructure. These factories need incredible amounts of power and ultra-pure water just to run.
So, the most crucial point to take away is this. We need to stop looking for a single problem to solve. The real bottleneck is the total integrated capability of our global system to actually design, build, and supply these impossibly complex products at the scale AI is demanding.
Which leaves us with a final, massive question. We talk about the potential of AI as if it's completely limitless, like it's just this force of pure information. But its entire existence depends on a fragile, complex, and deeply constrained physical supply chain. The ambition is digital, but the reality is physical. And you really have to ask, is our world truly ready to support it?